Okay, so this is going to be a quick review of our exponent rules notes that we took today, March 23rd. This is for 8th grade, so 6th graders, if you're watching this, click away. This is going to be a lot. Anyways, we went over 3 main rules when dealing with exponent rules. The first one we did was the product rule. The product rule states that when multiplying numbers with exponents, leave the base alone, add the exponent. You will multiply the coefficients if there are any coefficients. So what that means for this problem is, for example, let's say we have 4 to the third power times 4 to the second power. Our answer to this problem would be 4 to the fifth power. Now, the reason it's going to be 4 to the fifth is if you write out 4 to the third power, you get 4 times 4 times 4. If you were to write out 4 to the second power, you would get 4 times 4. That is a total of 5 4s that are all being multiplied together. That is why when you are multiplying two numbers of the same base with a different exponents, you would simply add them together, which it would be the same if they were the same exponent too. This can also be done for variables with exponents. For example, we have a to the third power times a to the negative first power. What you would do here is you would simply add those together. 3 plus -1. And we know that if we add a negative number, that is the same as subtraction. So we are doing 3a's minus 1a, and that leaves us with a to the second power. And to show you an example of what happens when there are coefficients, we have 2b to the fourth power times 4b to the third power. And this would work out to be 8b to the seventh power. So we will go ahead and multiply our 2 and our 4. After all, these are technically, if we read this whole problem out, we would read it as 2 times b4 to the fourth power times 4 times b to the third power. So we could rearrange this problem and go ahead and do the 2 times the 4. That's why we're allowed to do that with this problem. So we multiply those to get 8, and we combine our exponents, b to the fourth and b to the third, to get b to the seventh. And that's it for the product rule. The quotient rule is very similar. It states when dividing numbers with exponents, you will again leave the base alone and subtract the exponent. However, in the event that there are coefficients, you will divide the coefficients. So it looks like I accidentally left one of my examples blank. One moment. Okay, I'm back. So for this one, our example that I have up here is we've got 4 to the seventh power divided by 4 to the third power. And in this case, if I were to write all of this out, that you don't have to do this for every problem. I did this so you would have a visual of what's happening. We have 3 4s that are being multiplied on the bottom and 7 4s that are multiplied along the top. Naturally, these would cancel out to get 1, leaving me with 4 to the, that should say it's the fourth power, not to the third. Whoops, glad I caught that. Now, the same goes with when we have variables with no coefficients. We've got a to the eighth times b to the fourth all over a to the third times b to the second. What you're doing is you are going to focus only on the a's first, so a to the eighth and a to the third. 8 minus 3 would equal a to the fifth. And then you would focus on this. B to the fourth minus b to the second would be b to the second. So that's going to be our answer for this problem. Now, this one, I threw a bit of a curveball. Maybe I shouldn't have, but when we do our subtraction here, first of all, you would go ahead and divide 16 by 4. The coefficients, you would go ahead and divide. However, when we do this part, x to the fifth minus x to the seventh, we end up with x to the negative second. Now, in my class, we've gone over this in our warm-ups a couple of times that jump all over the place. What this means when you have x to the negative second power is you have x to the second power in the denominator. That's what that is going to mean. So we would take this and we would move it into the denominator. This will not happen as frequently, but it is something that we should have in our notes. And the last one, I could not for the life of me remember the title of this rule when I was going over it. The actual rule is power of a power rule, not distributive rule. I use distributive rule because that's really what is happening. When an exponent is applied to a set of parentheses, that exponent is applied to the coefficients, and then it also multiplies any existing exponents. You can see I messed up earlier when I was writing this down, but I'm leaving it there. So for this, what is happening? What I mean by it's applied to the coefficients and multiplies the existing exponents. If I have 3 to the second power raised to the fourth power, what that means is I'm doing 3 times 3 4 times. So 3 times 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 3. That is 8 threes that are being multiplied together. So we rewrite it as 3 to the 8th power. Okay? So we do that 2 times that 4. That's what's happening in here. The same goes if there are no actual numbers and we are just using variables. We have c to the fourth power times d to the second power, all raised to the third power. So what that means is we would do 3 times 4, and that gives me c to the 12th power, and 2 times 3, and that gives me d to the 6th power. Lastly, when we have our coefficients, what we're doing is we're going to distribute this 4 inside, so that way it gets applied both to my exponent and to my coefficient. So 2 to the fourth power, that would be 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So my whole number for this would be 16. And then we still have our variable n. And we have our coefficient, our exponent, 7 times 4, which would be 28. And that would be our answer for that. So these are the notes that we took today. We took notes on exponent rules, product, quotient, and power of a power rule, which I incorrectly called the distributive rule. If you need these notes still for whatever reason, pause this video, rewatch it, go over it with your parents if they don't understand it. And hopefully this helps. I did go easy on the homework tonight, so that way you would have time to do any missing work or late work. So good luck, and I'll see you later.